Have you ever stopped to think if there's some kind of hidden code behind the food we eat? You know, a universal blueprint that connects something like a chewy loaf of bread to a crispy cracker or a super tender piece of cake? Well, guess what? There is. And today, we're going to crack that code.
It really all boils down to this one question. And the answer isn't some kitchen magic. It's pure science. It's about controlling just a few key reactions that happen every single time you bake. And trust me, by the end of this, you'll see exactly how it all works.
So here's our game plan. First, we'll get into the 3 magic rules of baking. Then, we'll meet the 4 hero ingredients that make it all happen. We're going to follow a loaf of bread's entire life story, see what happens when you decide to break the rules, and finally, we'll dig into the science of why things go stale.
Okay, let's dive right into the heart of it. These 3 principles are the absolute foundation of pretty much all baking. I mean it. If you can wrap your head around these, you'll understand everything else.
First up, gluten formation. I want you to picture this like you're creating a tiny, edible net inside your dough. See, when you mix wheat flour with water, 2 proteins, called gliadin and glutenin, they wake up, link arms, and form this incredible, stretchy, elastic web. And that web is gluten. It's the entire structure of your dough.
So, you've built this amazing net. Now what do you do with it? Well, you gotta catch something. That brings us to rule number 2, gas production. We add yeast, which are basically these tiny little flavor factories. They munch on the sugars in the flour, and as they do, they release carbon dioxide gas. And all that gas gets trapped in that gluten that we just made, inflating it like millions of teeny tiny balloons. That's what makes dough rise.
And for the grand finale, structure setting. Once your dough is all puffed up and happy, you slide it into the oven. The heat does 2 things. It makes the starch swell up and firm up, and it cooks the gluten proteins. This process locks that beautiful, airy network into a permanent, solid structure. That's your bread's crumb. So think of it like a 3-act play. You build the structure, you inflate it with gas, and then you lock it all in place with heat.
All right, we have our 3 rules. Now let's meet the 4 core players, the team that makes this whole show happen.
What's so cool about this is just how simple the team is, but how powerful they are together. Flour, of course, brings the proteins that build our gluten net. Water is the activator. It gets the party started. Yeast, as we know, is our gas producer. And salt, salt is the unsung hero. It's not just there for flavor. It actually makes the gluten network stronger and, this is crucial, it acts like a referee for the yeast, making sure it doesn't get too wild and produce gas too fast.
And this is a really important point. Not all flour is the same. For that classic chewy bread with a really strong structure, you need a flour with a protein content right in this sweet spot, 11 to 13%. That gives you just enough of those gluten-forming proteins to build a really tough network that can trap a whole lot of gas. It's all about matching the right flour to the job.
Okay, so we've got the rules and we've got the ingredients. Now let's put it all together and actually follow a loaf of bread on its journey, right from the bag of flour to the finished product.
And here it is, the whole story in 6 steps. You can see how those rules we talked about play out. Mixing is all about building that gluten net. Fermentation is when the yeast makes the gas. Proofing is that final inflation period. And baking, that's when we set the structure for good. It's such a logical process, with each step perfectly setting up the next.
Okay, so we've just mastered the blueprint for bread, but this is where it gets really, really fun. Because once you understand the blueprint, you can understand almost any other baked good just by looking at how it intentionally breaks those rules.
And this comparison right here says it all. For bread, the #1 goal is to maximize gluten. You want it strong, you want it elastic. But for something like a biscuit or a cake, you want the exact opposite. Your goal is to weaken the gluten network. So how do you do that? Well, you bring in ingredients like fat and sugar. They literally get in the way of those proteins trying to link up, running interference. The result? A tender, soft, crumbly texture instead of a chewy one. And that's the big secret. The texture is all about how much you help or hinder gluten.
And you see this principle absolutely everywhere. Cakes create a delicate foam, and they often use baking powder for lift instead of yeast. Crackers can be fermented like bread, or they can use chemical leaveners for a crispier snap. And pasta goes all in on gluten, using super high-protein durum wheat to create a really firm structure that won't fall apart when you boil it.
So, for our final chapter, let's talk about the inevitable end for all these delicious things: staling. I mean, why does that perfectly soft, amazing loaf of bread turn into a hard brick after just a few days? You know, most of us think that staling just means the bread is drying out, but that's not really the whole story. The real reason is actually way more fascinating. It's all about what the molecules inside the bread are doing on a microscopic level.
The scientific name for it is starch retrogradation. So remember how the heat in the oven made all the starch molecules swell up and absorb a bunch of water? Well, as the bread cools and just sits there, those starch molecules slowly try to go back to their original tightly packed crystalline shape. And as they realign, they literally squeeze that water out. That's what makes the crumb get firm and what we call stale. So in a way, keeping bread fresh is really just a race against recrystallization.
So the next time you bake a loaf of bread, or bite into a cookie, or even just boil some pasta, you'll know the secret. You're not just cooking, you're basically a scientist in your own kitchen, tweaking proteins, starches, and gases to create something delicious. It's all right there in the universal blueprint of baking.